Welcome back. Today we're going to talk about measuring the center of a data distribution. And one of the things that I really want to hammer home is there's a lot of different ways to measure the center. And the center is one of those key pieces that we're really going to look at when we're talking about describing distributions. So when you're looking at the AP test, remember, we're talking about shape, we're talking about centers, we're talking about outliers, we're talking about variability. We're looking at data and we're looking at graphs and we're describing what's going on. So let's start with the mean here. And so when we're looking at the center of this data, there's a couple ways to do it. Let's talk about first about the mean. And what I'm going to do is I'm going to go through some of the ways that we would denote this, right? So some of the ways that we can talk about it and some of the statistical terms and some of the symbols that we're going to use. So for the mean, in statistics, the mean is going to be recognized by X bar. And so X bar is the mean. And we know mean, another way that we say it a lot of times is average. Right? So the average is the mean. And the way that we find that is to take the sum of all of the elements X and divide by the number of things that we have. So you got 20 things, you add up all 20, you divide by 20, that's how we find the average. Okay, median is another way. Median is the middle value. In a set of ordered values. So it's the middle value in a set of ordered values. So for example, one of two things could happen. Either we have an even number of things or an odd number of things. Let's say I have some items here, 0, 1, 2, 3, 6. Then my median value, you take it to the middle. And the most common way that people do this, so this would be the way that people cross out one from each side. And so this is my median. Or we could have a set of values where there's an an even number of values. So I've got 0, 2, 3, 4, 6, and 9. So there's 6 values here. So if I cross out, come to where there's 2, and so I find the average. So I do 3 plus 4 over 2 would give me 3.5 is my median. So when I have an odd number of values, the median is actually on one of the data points. When I have an even number of values, it's the average of the two middle ones. Okay, so let's do something with this. Here's the center of this, the cereal sodium data problem. So we are looking at the amount of sodium in a given cereal, and so I need to find both the mean and the median. To add them all up, you add them all up on your calculator. So what you can do is right now I would suggest pause this video, try this, and when you unpause it, I'm going to do these two problems. So I already have them done on my sheet. I'm going to show you how to do them, and but if you want to try them and see if you get them right, pause it now and pause them and do the problem and then come back. Okay, so when I did this, we're back from the pause. The mean was 167. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 values. So I take the total, divide by 20, that is 167. All right, to find the median, I've got to put them in order. Sometimes this is a little bit tricky. I'm going to show you something that helps me. So if I put these in order, what I'd have is 0, 50, 70, and then 100, 130, and 140, 140. Then I've got 150, 160, 180. Now, a lot of people, and I used to do this, I used to put them in a big long line, and the advantage of that is you can cross them out pretty easily. Well, think about it like this. If I know I have 20 data points, what I can do is if I put them in 2 columns, then I can more easily count, I can make sure I have everything, and I can easily see kind of everything that's going on. So I'm going to put my next set of data values right underneath. I'll continue on with 180, 180, 190. And again, I put these in order while you were like while you were paused, right? So I already had these, so you should have done this while you were paused. So then I've got 210, 210, 220, 290, and 340. Okay, so what this tells us is, where's our median going to be? Well, if I come to the middle, right, there's 20 values, so these two are going to be my median. Like it's an even number of values. Obviously, 180 plus 180 divided by 2 is 180. So that's my median is 180. And so those are different, which is okay. They're going to be different probably most of the time. Not always, but most of the time. And that's going to be something that we discuss here coming up. All right, outliers. Outliers is another one of these things up here, right? So we talked about center. So the big things that we're looking for, SOCV, right? So this is shape, outliers, center, which is what we're talking about today. And this is variability, like how much does the data vary, which is fine. Today we're talking about center, and then we have to have a note about outliers, because as you kind of can imagine, if I paint this picture for you, let's say you've got a bunch of 95. So you have 4 tests for the quarter, and you've got a 95 on every single one of them, and then you get a 0 on the last one. Let's call it 15%. Well, that abnormally low value, what's it going to do to your grade? And you're probably sitting there going, ooh, yikes, it's going to bring it down, right? And so outliers have a big effect on mean, but do they have an effect on the median? Think about that for a second. Now, to call something an outlier, that's actually, the technical term outlier is a calculation that we'll learn about. We're going to learn about what that calculation is in the next section. But in order for us to be able to say, hey, there's an outlier, we should do that calculation. But we can always say there appears to be an outlier. So an outlier is a really big or small data point. And what we would say is, like if you see one that looks like it's way out there, either high or low, just say potential outlier. Or possible outlier. And the cool part about that is you are showing that you know what an outlier is, right? It's a really big or really small value, something outside the main chunk of data, but you're not committing to the computation of that outlier, okay? So that's pretty cool. All right, let's look at an example, CO2 population. The Pew Center on Global Research Climate Change reports that global warming is largely a result of human activity that produces carbon dioxide emissions and other greenhouse gases. The CO2 emissions from fossil fuel combustion are the result of electricity, heating, industrial processes, gas consumption, and automobiles. The International Energy Agency reported their per capita CO2 emissions by country, that is the total CO2 emissions for the country divided by the population size of that country, for 2011. For the 9 largest countries in population size, which make up more than half of the world's population, the values were in metric tons per person right here. All right, so it wants us to make a dot plot of this data. And our dot plot of this data could take the form of a couple things. So let's look at our data for a second here. And what I like to do sometimes is I just like to lay it out in order to see what we've got. So I'm going to go 0.3, then 0.4. And I'm going to have, let's see, 0.8. I see that down there from Pakistan, right? And then I've got 1.4. What else have we got? Then 1.8. Then, so 1.4, 1.8, 2.1. 5.9. 11.6. And 16.9. Yikes. Okay. So here we go. So making a dot plot of this data is going to be a little bit tricky. And so what I want to do is I need to figure out, what exactly am I trying to do here. So let's see. Let's get black here, make a big long straight line here. So here's my line for my dot plot. And I've got to go up to, 17 at least. So let's make this 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Ran out of space. 14, 15, 16, 17. So here's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Woo! Okay. All right. Now, the cool part about making a dot plot is we can put in the values and they can be on sort of a continuum, right? So these aren't categorical data. This is quantitative data. So the data is going to be on the continuum, right? So I've got 0 and 1, but I could put 0.3 in here. So let's put 0.3 right here, and 0.4 is here. 0.8 will be here, and then I'm going to go 1.4, and then, goodness, 1.8, and then I'll have 2.1, a lot of data values packed in here. And then I've got 5.9, I've got 11.6, and then 16.9 is way up here. Well, holy cow, look at how spread out this data is toward the end. A lot of data values packed on the one side, not a whole lot on the other end. So it looks like there might be some potential outliers here, right? So let me look at this and think about what these questions are asking. For the 9 values, the mean is 4.6. What's the median? Well, I put them in order already, so let's find our median here. So I've got cross and cross, oops, cross and cross, cross and cross, cross and cross. My median is 1.8. Well, what does that tell me? So my mean is 4.6. My median is 1.8. So check it out. Is any observation a potential outlier? Yes. 16.9 and potentially 11.2, right? The impact on the mean. Well, think about it. My median value, my middle value is 1.8, meaning the middle of the data when you put them in order is 1.8. The mean is significantly higher. Okay, so the mean is significantly higher. So outliers can significantly change the mean compared to the median. Right? So the median value gives me one way to measure the middle, okay, and it's got a significant impact. Well, that's significant, right? Because we can actually generalize this. Outliers and distribution seeks to do just that. So let's take a look. Let's say I have some data, and it falls under one of 3 categories. We've already talked about these 3 categories, so I'm going to draw all 3 of them. I've got my types of distributions here, so this is going to be a discussion of a little bit of shape, right? So here's one. This one's symmetric. And my next type of data is going to be skewed left. And my next data is going to be skewed right. And there's a significant way that the mean and the median are affected. You need to know this. You need to be able to generalize this. So the mean in truly symmetric data is equal to the median. When it's skewed left, I'm going to have 2 different things. Here's going to be my median. And my mean is going to be over here.
Lewis, please come to the high school office.
And so what you'll notice is the mean is skewed to the tail, right? I've got this data way out here, the huge values over here that are going to skew my mean that way. Less skewed data. Here's my mean. Here's my mean. Sorry, that's my median.
Caitlin Plunkett, please come to the high school office. Also, Cairo guys, you will be meeting in Mr. Ashcraft.